Hello everybody, it is Aladdin Physics here with a physics video for O-level students. We are looking at the chapter of radioactivity, and our main focus in this video will be the half-life. When a sample of radioactive material decays, it does so exponentially. Therefore, we have the term called half-life that we can associate with a radioactive sample. So the half-life is the time taken for the number of undecayed nuclei in a radioactive sample to become half its initial value. So pay attention to the word undecayed. Let us say we have 200,000 undecayed nuclei at the start, and let us say that 50,000 decayed in a period of time. Therefore, we are left with 150,000 undecayed nuclei. Now let us see what is happening on a graph of number of nuclei versus time. So initially we have n-node number of nuclei. It is important to understand that here the number of nuclei means the number of undecayed nuclei. After one half-life, the number of nuclei becomes half its initial value, which is simply 1/2 of the initial value. After two half-life, the number of nuclei becomes 1/4 of its initial value, which is simply 1/2 to the square of the initial value. After three half-life, the number of nuclei becomes 1/8 of its initial value, which is simply 1/2 to the cube of the initial value. Now let me elaborate a bit more on the half-life concept. If we have initially 100,000 nuclei, then after one half-life we have 50,000 nuclei. Then after two half-lives, we have 25,000 nuclei, which is 50,000 divided by 2. And it is also 100,000 divided by 2 to the square. Then after three half-lives, it becomes 12,500, which is 25,000 divided by 2, or 100,000 divided by 2 to the cube. Lastly, after four half-lives, it becomes 6,250 nuclei, which is 12,500 divided by 2, or 100,000 divided by 2 to the fourth. So let us have another example. Let us say we have 600,000 nuclei, and let's just say that the sample has a half-life of 40 minutes. After 120 minutes, I want to know how many nuclei will be left. So 120 minutes is equal to 3 half-lives. Therefore, the number of nuclei after 3 half-lives is a number of nuclei divided by 2 to the power of 3, which is equal to 75,000 nuclei. Let us have another example. Consider here a radioactive sample containing 180 million nuclei. After 20 days, the number of nuclei becomes 11,250 nuclei. What is the half-life of the radioactive sample? So here we start with 180 million nuclei. Now to become 11,250 nuclei, we see that if we divide it by 2 to the power of 4, we will obtain 11,250 nuclei. So the number 4 here is simply the number of half-lives. So 4 half-lives is equal to 20 days, and therefore 1 half-life is 5 days. So what do we measure in radioactivity? Here is a typical setup doing measurement in radioactivity. We have a sample. The sample is enclosed in a lead box with only one opening. The lead box is present to prevent the room from being contaminated with ionizing radiation. The apparatus that we are going to use is a GM tube in order to detect the radiation, and the GM tube is connected to what we call as a counter. When an ionizing radiation or particle enters the GM tube, the counter will register a count. The ionizing particles are alpha, beta, and gamma. The count or count rate will be reported by the counter as 200 counts or 200 counts per minute. The count or count rate is simply the detected number of ionizing particles emitted in the direction of the GM tube. The count or the count rate will also decreases exponentially with time. After 1 half-life, the count or count rate will become half its initial value. After 2 half-lives, the count or count rate will be 1 over 2 to the square of the initial count or count rate. And after 3 half-lives, the count or count rate will be 1 over 2 to the cube of the initial count or count rate. So let's have an example. The count rate of a radioactive sample drops from 1200 counts per second to 150 counts per second in 3 minutes. Calculate the half-life of the radioactive sample. So if we take 1200, divide by 2 to the power of 3, we are going to obtain 150 counts per second. So essentially the aim is to find the number of half-lives in 3 minutes. So here we have our 3. So it means 3 half-lives is equal to 3 minutes. 1 half-life is 1 minute. So if you have enjoyed the video, don't forget to subscribe, like, and share the video. Thank you very much. Until next time.